In this video, I am going to discuss about Biot-Savart's law, or which is also known as Laplace law. We know that a moving charge will produce the magnetic field around its surroundings. So similarly, whenever we say that in a conductor there is a current is nothing but it is rate of flow of charges. Therefore, the charges which are in motion inside the conductor, they should produce the magnetic field around its surrounding. The amount of magnetic field produced by the current carrying conductor or the current which is flowing in the conductor, it was given by the scientist Biot-Savart. So it is known as Biot-Savart's law. According to his statement, he says that the magnetic field produced at a point due to a current carrying conductor, or if you consider a small portion inside the if you consider a small portion of the conductor which is called as current element of very small length dl, he says that a small conductor, a small current element carrying current produces the magnetic field around its surroundings, and this magnetic field is directly proportional to the current through the current element. It is directly proportional to the length of the current element. The magnetic field is directly proportional to the sine theta, where theta is the angle between the current element and the line joining the point of observation, and it is the magnetic field is inversely proportional to the square of the distance from the current element to the point of observation. Combining all these 4 points together, we can write dB is proportional to I into dl into sin theta, I into dl into sin theta divided by r square, or dB is equal to some proportionality constant k into I dl sin theta divided by r square. In SI system, the value of this proportionality constant k is mu naught divided by 4 pi, where mu naught is known as permeability of free space and its value is 4 pi into 10 to the power of minus 7 Tesla meter per ampere. By substituting the value of k in this expression, we will get dB is equal to mu naught divided by 4 pi ideal sin theta divided by r square. This is the magnitude of magnetic field produced at the point P, which is at a distance r from the current element, which is making an angle theta with the line which is joining the current element to the point of observation. This is only the magnitude. If we want to write the vector form of Biot-Savart's law, then let us multiply and divide the right hand side of this expression with r. We will get dB is equal to mu naught divided by 4 pi I into dl into r sin theta divided by r square into r, it is r cube. dB is equal to mu naught divided by 4 pi I as it is dl vector cross r vector divided by r cube. Since the vector product of two vectors is a vector, therefore dB is vector. You can check here, vector dl cross vector r, magnitude of dl is dl, magnitude of vector r is r, and sin theta, where theta is angle between vector dl and vector r. Since the vector product of two vectors is a vector and the direction of this resultant vector is always perpendicular to the plane containing other two vectors, therefore here if you assume that the current element is on this plane of the board and the point of observation is also on the plane of this board, then the magnetic field produced by this current element should be perpendicular to the board. Okay, it may be coming out of the plane of the paper, or the magnetic field may be going into the plane of this board. It can be decided by knowing the direction of current in the conductor.